We'll continue with lesson 1.2. This is Precalculus. We'll jump over to our notes. We want domain and range. We're following along in the textbook. And the first thing we get to is this table here that talks about how to write various solutions. This comes in handy for our domain and range and when we write that down. Let's talk about our first problem, though, when we think about domain and range. These are the 1, 2, 3, 4, 5 points that we have. If you're a visual person, you can think about graphing these. You have inputs, that's the first number, and then you have outputs. So it looks like we've got a 2, a 3. Math is a visual discipline, as well as an analytical one and a verbal one. Okay, so at 2, we have a value of 10. At 3, we also have a value of 10. At 4, we have a value of 20. It looks like at 5, we have a value of 30. And at 6, we have a value of 40. So this is what this looks like. Okay, so domain, if we scroll down a little bit, is the inputs. So if this is everything in our function, then our domain is 2, 3, 4, 5, and 6. We don't have anything between those points. And the range is going to be the outputs. And that, in this case, is 10, 20, 30, 40, and that's it. There are two things that make us restrict the domain. Those two things. When we divide by 0, and when we take square root of a negative number. Okay. We will restrict the domain when we divide by 0, or we take the square root of a negative number. We can see an example of this. The only time we have an issue is when the denominator is 0. We have an issue when 2 minus x is equal to 0, because that means we will divide by 0. So what would make the denominator 0? Well, we see that if x is equal to 2, then the denominator will be 0, and we have an issue. So for this example, we're going to say that the domain, DOM, is all real numbers except x equals 2. Example 3, we have f of x is equal to square root of 7 minus x. We can take the square root of 0, that's equal to 0, because 0 times 0 is equal to 0. And we can take the square root of positive numbers, like 9, because square root 3 times 3 is 9. As it turns out, there's two answers. Negative 3 times negative 3 also is positive 9. So keep that in mind. However, square root of negative is undefined. It is defined, and we'll see that this can be an imaginary number. So when we talk about real numbers, it's undefined. Where does that occur? Well, I'm going to think about the number line here, and I'm going to find out when is the stuff beneath the square root symbol, when is that equal to 0? We call that the argument. When is 7 minus x equal to 0? And we see that x is 7, making this equal to 0. So x is 7 is important. Now, what side of 7 can we be? I know I can be 7, so I'm going to circle that in. And if I'm anything bigger than 7, this becomes negative. So I don't want to go to the right. I want to go to the left. If I put in x is 0, for instance, something to the left of 7, I could test this out. Square root of 7 minus 0 is the square root of 7, and that's some number that we can calculate using a calculator. Though by hand is possible too. To the right, we don't have any values, so we don't include this. So if we were to write the domain, we could say that x is less than or equal to 7. We have a graph that shows us the solutions to a problem. That graph goes from -2 to 7. And we have solutions from 1 to 3. We can include 1 and we can include 3. And everything in between. And we can go from 5, but not including 5, so we use an open circle. And we can go all the way to the right. And we keep going past 7, so we include an arrow. We have different ways that we can write this solution. There is inequality, set builder, and interval. So inequality notation, we would say that 1 is less than or equal to x is less than or equal to 3. They're using the word or. Or x is greater than 5. There's the set builder notation. That uses these curlies, x, such that, and it's kind of like you use the inequality notation now, 1 less than x less than equal 3, or x greater than 5. And then you end with the curlicue. And there is also the interval notation. These are 3 different ways of saying the same information. Now, we included 1 and 3, so we use the brackets. But we did not include 5, so we use a rounded. And since we can go all the way up to infinity, we also use rounded. So we don't include 5, and because infinity is an idea, not a number, we'll also use this rounded notation. Okay. The domain and range from graphs is nicely seen in this graphic, where we have left, right, the domain, and up and down is the range. So wherever our graph may start, in this case at -5, 5, and then drops down, and will go all the way to -infinity, as it turns out. Other graphs may be pieces of graphs, which leads us into the idea of piecewise functions. I think this is an interesting graphic, and we could take a look at this, and we can ask ourselves, what is the domain and what is the range? What are the input values, years here, shown across the horizontal? And what is the output in thousands of barrels per day? Okay. We have some functions that are part of our vocabulary. This is a linear function, a line. The domain goes from negative infinity to infinity, and as does the range. We have the absolute value graph next. You'll see that we can put in any x value, negative infinity to infinity, but we'll never go less than 0. The quadratic, the parabola, you can put in any x value because you're not dividing or taking square root of a negative, not dividing by 0 or taking square root of a negative. The range, however, is only from 0 to infinity. It's only positive. We have the cubic function, this stretched out thing. It does have any x input, so negative infinity to infinity, and we do get every possible y value out, negative infinity to infinity. I do like the reciprocal function. It has 2 parts and an asymptote at x is equal to 0, as well as y is equal to 0. You'll notice the domain, they're using this U symbol between these two. So some of our set notation here. So we don't touch 0 either for x or for y. The reciprocal squared function, well, it takes that negative part in the third quadrant and puts it positive in the second quadrant here. And so you'll see the range is slightly different, though the domain is the same. Square root function, you cannot put in a negative value, so domain x values are only 0 and positive, and that means the range also is 0 to positive. The cube root function is a reflection across the line y equals x. It's the inverse of x cubed, so cube root and x cubed are inverse functions of each other. And you can kind of see that now we have this sideways S thing. Domain and range, negative infinity to positive infinity. We have some questions here. Again, we're cautious when we see division and when we see square root. Any even root, so the fourth root would also be an issue. Piecewise functions will have different parts, and so may have graphs that don't look like something we have seen before. And that's okay. So oftentimes they will be straight lines that meet at some point and then maybe change angle. This is often our clue for piecewise, or in this case, we have 3 different pieces and we can get this graphic that is interesting.